What's up, geeks, and welcome to the channel. Suppose we're working on the notification service of our famous food delivery application. The service notifies our customers about important events, such as delivery departure and arrival, order receipt, etc. Okay, the initial version of this service was made of the notifier class you see in front of you. This class housed a single send method. This method could accept a message argument and send this message to an email which is retrieved from the username via a database service class. Now, at some point, you realize that our customers expect more than just email notifications. Many of them would like to receive a WhatsApp message about their deliveries, for example, and others would like to be notified via Facebook. How hard can that be, right? And the first thing that comes to mind is, of course, inheritance. So you extended the notifier class with two new subclasses, the WhatsApp notifier and Facebook notifier classes. Now, the client is supposed to instantiate the desired notifier class and use it while notifying a particular customer. However, one day, one of the customer approaches you politely and says, "Why can't I be notified via WhatsApp and Facebook at the same time?" Well, with the current design, the solution to this problem would be to create a new class that will notify this customer using both Facebook and WhatsApp. But notice how this approach would overwhelm the code immensely when you try to add a third notifier, like SMS for example. You can clearly see that by adding this single additional choice, the number of subclasses we have are already hard to keep track of. The solution to such problems is following and applying the Decorator Design Pattern. The Decorator Pattern is a structural design pattern that lets you attach new behaviors to an object by placing this object inside a special wrapper object that contains these behaviors. Let's try to apply that on our notification service example. To do that, we will keep the main component of our app, the notifier class, intact. However, concerning the Facebook notifier and WhatsApp notifier classes, these classes will be renamed to Facebook Decorator and WhatsApp Decorator and will now extend a base notifier decorator class. This base decorator class is the wrapper or the container of our initial notifier. The next and most important step is to make all the classes we just saw implement the same interface. Let's call it iNotifier. And it is this interface that will be used by our classes across all our application and by the wrapper class as well. Why is that? Well, to understand this, let's take a step back and take a look at the decorator's definition mentioned a few seconds ago. We said that decorators are wrappers for our core objects, and wrapping enforces us to replace the inheritance we've been using with composition. An advantage of composition is that you can easily substitute your objects with one another because all of them belong to the same interface. This allows you to change the behavior of the container at runtime. On top of that, an object can use the behavior of various classes, not only one, as it can reference multiple objects and can delegate them all kinds of work. Now, the rest of our code won't care whether it works with the initial notifier object or the decorated one, since all decorators implement the same interface as does the base notifier class. As you can see in this example, the wrapped object provided to the Facebook decorator is itself a WhatsApp decorated one, which was provided with a simple notifier, meaning that the Facebook super.send method call will invoke the WhatsApp super.send method, which will invoke the base email notifier send call, leading to the output you see in front of you. Okay, now that we've implemented and applied the decorator pattern, let's take a look at its structure or class diagram, all while trying to relate it to the notification example we just saw. The first thing you may have noticed is the component interface, which was represented by the iNotifier interface in our example. This interface declares the common behaviors for both wrappers and wrapped objects. Next is the concrete component, which of course was the notifier class in our example. This is the wrapped class. It defines the basic behavior which can be altered by decorators. Speaking of which, the base decorator, or base notifier decorator in our case, must have a field for referencing the wrapped object. This should be done via the interface so it can reference both the concrete component and its decorators. This base decorator can and is most probably extended by concrete decorators. In our example, we had both the Facebook decorator and What's Up decorator classes. These decorators override the methods of the base decorator and execute their behavior either before or after calling the parent method. Calling the parent method is a must. Finally, the last piece of the diagram is the client. The client can wrap components in multiple layers of decorators as long as it works with all objects via the component interface. So, to sum everything up, the Decorator Design Pattern wraps an existing object, allowing you to add a new functionality to that object without altering its structure. By doing that, you will be able to assign extra behaviors to your object at runtime without breaking the code that uses that object. Additionally, by following the decorator pattern, you will be applying the single responsibility and the open-closed principles because each behavior you added is isolated in a separate class, and you now have the ability to introduce new decorators without modifying the existing object's class nor the decorators previously created for that object. So, that's it for this video. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.